and we're back with studying for your Algebra 1 final exam in the first semester. Let's look at this problem. It's a super common, popular one, and the idea behind it is we have one family that's doing something, another family that's doing something else, and we have adults and children. And the general idea behind it is we figure out how much it costs the adults to do something, how much it costs the children to do something, and we use that to answer the question. There's a two-step process to this. The first step, I think, is actually setting up a system of equations, and then the second step is going to be actually solving and finding our answer. So let's do the setup first. Setup-wise, we have one family paid $70 for 6 adults and 2 children. Do we know how much the adults paid, how much the children paid? We don't. So maybe let's define some variables. Let's let A be how much, or no, maybe we should probably put it as the cost of an adult's ticket for the Aces game. And then let's have C be the cost of a child's ticket. So if 6 adults paid for tickets, then that means that we had 6 adults that were paying some price. Let's say the price was $10. We'd do 6 times 10, they paid 60 bucks. And then we had 2 children that had to pay children's prices. And when they did all that, that ended up being $70. Okay? Our second family here, we have 3 adults and 4 children. And when we do all of this, that ends up being $59. Well, in order to solve this, we need to be careful about our method. I see 2 options here. Option 1 is we could multiply all of this by -2. That would turn this into a -4, which would cancel out this +4, which is awesome. The second option is we could multiply this bottom by -2, and that would turn this into -6a, which would cancel the +6a. So maybe the question we should ask is, which variable do we want to go away? And since we want to figure out how much an adult ticket costs, we don't need both. Let's try to minimize our work here. If we want the adult ticket cost, then we don't want adults to go away. We want children to go away. So let's make children go away by multiplying both sides, do you remember? By -2, because that will turn this into -4, which will cancel the +4. This gives us -12a minus 4c equals -140. And on the bottom, we end up with 3a plus 4c equals 59. You might want your calculators for this part, or we can just laugh and see how badly I screw it up. That's okay. Our c's are going to cancel. -12 plus 3 is -9a. -140 plus 59, oof. I'm looking at 90, nope, 80, 81 I think. Yeah, it seems like 81, and don't forget that it's negative. I'm pretty confident on 81 because 9 goes nicely into 81. Now, notice over here we have some non-nice answers, but let's start with the nice one. If we divide by -9, we find that an adult ticket costs $9 per ticket. Okay, we could have also found the cost of a child's ticket and then plugged that back into our equations to find an adult ticket, but I think this way is probably the fastest. Good luck.